right now we're in a position where we've got a set of mechanisms for financing innovation which are pretty well understood. The VC model is something like 50 years old, investment banking maybe a couple hundred years old. Everybody has a basic model of how all this stuff goes. The question is, how does the ICO world, with its enormous ability to generate capital on target very, very quickly, integrate into the much wider global innovation need? So the basic question is, why can't we build more amazing stuff, right? You know, the world is filled with mega projects like Hyperloop, like the Mars mission, like the hard end of AI, like all the geoengineering stuff you might want to do to try and combat climate change, general purpose robotics. It's filled with these kind of, multi-billion-dollar spend projects, which it's more or less impossible to finance inside of the existing systems without massive government intervention. Tesla, for example, had something like $5 billion of US government loans, but this is not going to scale for all projects. The core issue here is that the innovation economy that we're used to was almost entirely government funded up until about the 1970s. There was basically a century of massive government spending on these kind of mega projects, and it lays down a framework of innovation that then continues to pay dividends for the next 30, 40, 50 years as the incremental innovation is mined out. So if you think about the Manhattan Project and the American moonshot, all of that kind of stuff that comes out of the Manhattan Project and the Apollo program then goes in to become the foundation of Silicon Valley, right? You start with these kind of private enterprise projects and you think, oh, this is all of our wonderful entrepreneurial activity, but it's built on 30, 40, 50 years of spending that lays the foundations on which that stuff grows. And because the innovation boom is going so nicely in the 70s and 80s, the government stopped doing this kind of heavy investment and say, well, it's obvious that free enterprise doesn't need any help. And then the mega projects stop getting built. One thing I'll note is that free software kind of makes an exception to this because it finds a new economic model for spreading the entrepreneurial risk of building these kind of mega projects. So the free software ecosystem is estimated at being worth something like $150 billion, could be more by now. And that enormous creation of wealth is possible because of sharing, right? It's the IP licensing that permits that explosion. But for things that you can't do that kind of innovative licensing for, it's very hard to capitalize mega projects. So my suggestion is that with a little bit of work, we could reorganize the way that we think about the ICO in a way that would give us the potential to fund these kind of mainstream, mainline, heavy engineering mega projects and kind of get planetary civilization back on track towards this kind of high-tech future that we could have if we don't wind up simply racing to the bottom on margin shaving as the primary application of technology. So the appetite for capital, I mean, if you just sit down and think about all the science fiction stuff which is just about buildable right now, right? Space elevators, they're right on the edge of material science, everything to do with humanoid robotics, everything to do with getting AR and VR up to the point where they're indistinguishable from the real world, everything to do with direct neural interface like Elon Musk's work on neural lace. All of this kind of stuff is in a position where it's just looking for finance. The technical capabilities are just about there. There's no doubt at all that if you did a 5, 10, 15, 20-year heavy spend burn to get that stuff real, it would become real. The thing which is missing is the finance, and it's very hard for people to put money behind stuff that they don't understand. How are we to tell when somebody comes up to us with a scheme for one of these kind of mega projects, whether what they're selling us is a perpetual motion machine? How are we supposed to differentiate between the projects that we should be putting this kind of global capital behind and the projects which are basically just shenanigans? How are we to tell? So my suggestion is that in the face of this kind of uncertainty, right, when you think about the cold fusion thing, 30 years ago, 40 years ago, we're still not entirely sure whether that was real science or not. In the light of this kind of uncertainty, we need some kind of intelligent approach to managing the risk, right? Because if we try and tell the regulators in the world, look, we just want to burn, the entire risk capital of society on unproven mega engineering projects, they're going to give us a really hard time about this, and rightly so. The reason that Scotland became unified with England is because of a thing called the Darien scheme, where the Scots invested something like 10% of the working capital of Scotland in attempting to set up a colony somewhere outside of Panama that turned out to be a disaster. and the following financial crash was so bad, and it hit the working capital of the economy so badly, there was nothing left to do but give up sovereignty and unify with England. And the real world consequences of these kind of bubbles and crashes are extremely severe politically, and the state will try and prevent that stuff happening. This kind of stuff, right, is as much to protect the government from the volatility that results in society when you get hard crashes as it is to protect individual investors. There are social imperatives that they're trying to protect. Stock market crashes in the 1920s. In the 1930s, America becomes dramatically politically unstable. This is not just an individual investor imperative, it's actually about the stability of government. So here's my suggestion. Right now, the accredited investor frameworks, which are used all over the world, that are designed to protect investors, basically measure wealth. The assumption is that once you've got a few £1,000,000 spare, a few $1,000,000 spare, you ought to be allowed to burn that money any way you like, including investing it in questionable things. And this is okay up to a point, but it's then also coupled with the enormous protective systems that run around things like IPOs. They work very, very, very hard to make sure that the stuff which is offered to the general public through the IPO mechanisms is, frankly, practically zero risk. It should have commercial risk, it shouldn't really have scientific or technical risk. And the inability to put big money behind scientific and technical risk is why we can't get the big stuff done. We're tying the hands of our innovators because we won't let the finance chase scientific and technological innovation past a certain point of risk. And the really big rewards are at least that level of risk, if not higher. So, notionally, we could accredit investors for their technical knowledge. You could go and say, okay, well, look, you've got a master's degree in computer science and you've got 10 years in the field. You ought to be able to assess whether or not a piece of software technology is feasible. And at that point, we can accredit that you're a technically sophisticated investor inside of software technology, and you should be allowed to put money behind anything you like. And that's a relatively small change to the current investor regulation landscapes, but it's the kind of change which could open up the legal side of the ICO markets, on an enormous scale. Because there are probably 2, 3, 4 million people who would be able to pass some kind of certification process as a software technology investor, and those people have a combined disposable income of many billions of dollars a year. Right now, the majority of that income is not investable because most of those people are not accredited investors, and they can't become accredited investors under the current regimes. So the opportunity here is for government to make a relatively small regulatory change, which is opening up a new class of accredited investors, and then that stabilizes the legal status of the entire ICO market because only people with that investor certification can participate, which basically means that technologists are funding other technologists, which is the way that venture capital was when venture capital was effective. Does this kind of make sense? I mean, it's a very straightforward proposal. It's not all that ambitious. The ambitious part is what comes next. So the thesis is that all this stuff has to get funded. Government wants it funded, society wants it funded, it may be that civilization needs it funded, and the thing that's getting in the way is this accredited investor certification. We've taken down all the transactional barriers because the blockchain allows us to do the transactional side of this kind of mass investment strategy really, really easily, but what we don't have is the legal right to do this stuff. And as you've seen recently with the Chinese government rewinding all of the ICOs that happened, there's a real stressor here about whether or not we're going to let people do this stuff or not. The idea that they rewound all these ICOs and people had to put the money back where it came from, that's an entire set of innovation which will simply never exist because the money is gone. And that could happen to almost anything. We need to get this stuff on a solid legal foundation before we can go forward to do things like the mega projects and the big engineering. So, that's how we're going to pay for this, right? The sensible approach to funding the kind of mega spends that will be required to do things like go to Mars is that we need to open up the legal structures necessary by accrediting investors based on their technical sophistication. And then, once those doors are open, we could do large-scale organization of capital using the blockchain to get everything organized to take these kind of risks. Simple story. Now, wrong slides. Guys, there's a second copy of that slide deck that was the late night update. Mo asked me to change a couple of things. There are like 5 more slides. It's in the same shared folder. Sorry about that. Any questions, just while they get the decks organized? We got about a few seconds while they switch them over. what I'm going to talk about next is how we build courts that have the ability to handle this kind of risk and this kind of technical sophistication. Because the existing legal structures that we have are very bad at handling litigation in high-risk, high-technology cases. So the problem, when you get into this kind of hard grind, is it becomes very, very, very hard to get a court to adjudicate on whether something is a responsible legal contract. So when you get extremely large-scale litigation between tech companies over things like patent portfolios, these are $100 million court cases. They're incredibly expensive, and it has an enormous chilling effect on innovation. So the suggestion that I have is that it's possible to build private courts using a mechanism called arbitration and international arbitration. And these private courts have the ability to create opt-in private law. So two parties to a contract, for example, all of the people that are interested in funding some kind of large-scale high-tech mega project, sign up to a private court system which is operated by independent, neutral third parties with high-level technical expertise. And these systems are handling hundreds of major cases a year. We're talking about tens of billions being transferred. And they're completely reliable, they're completely solid. They draw their force from a thing called the 1958 New York Convention, and they're binding in 160 states. So with this architecture, you can take your smart contract mechanisms, which provide all the sophisticated handling of money in ultra-low-cost transactional environments, and you can pair them with private enforcement that has the ability to make those contracts legally binding and legally enforceable in 160 countries. And that is an architecture on which you could build a really substantial step function change in our ability to do innovation globally. We are building the first court of that kind right now in London in tight cooperation with the City of London, and it's called Materium. And if you're interested in more information, there's a white paper on materium.com, and we're basically partnering with organizations right now to connect them to those court systems and to verify that their smart contract ecologies are suitable for use in those courts. And we're open for business. I'll leave you with that for more information. Thank you very much.